All right. Well, welcome back to this wonderful Labor Day. Today we're. Oh, come on! Really?
We should have a 3-day week.
Yeah. What?
We shouldn't be having a 3-day week.
Why?
Everyone else is. Well, yeah, a lot of us shouldn't be here. Yeah.
Why shouldn't we be here? Oh, I can't wait to hear this.
Every public university's out.
Yeah.
Well, that's just because we're better than them.
Okay.
We want our students to study harder.
Yes.
Yeah.
And actually labor on
Labor.
Day.
I don't want to.
I mean, we don't get a break, you know.
That's right. Well, that's also why we start a little later and we end a little earlier and we get a whole month, pretty much the whole month of December.
Anymore.
Wow.
Never satisfied.
Never satisfied.
Never replaced.
All right. Well, today we'll talk actually about C++ arrays, but also we're going to talk about object-oriented programming in C++ versus Java. And while it's going to look very similar, there's some big differences that'll pretty much get you if you don't keep them in the back of your mind about what's going on. And we'll also do a review of pointers. We'll do another presentation on pointers. How's pointers doing? Everyone got it? Did anyone do the homework?
I got to number, what is it, 15?
Number 15?
Yeah. We have to write out all the problems. I'm like, 4 points. It's going to be a tough one.
Oh, okay.
So I shelved it for now. Almost done.
Almost done? Okay. All right. Okay. Let's go and get started. C++ versus Java with OP. Both of them, they're enforced via keywords. So public for an interface, private to make implementation inaccessible and protected, access for only the subclass. Java is the package, but C++ it's pretty much any subclass. So public, private, and protected, they're going to act or behave just like they would in Java. So that's good. Nothing new there. You type them out a little differently. In Java, each member is prefixed with keyword. But in C++, you kind of have this public, private, protected sections. So let's go over here and at least start looking at what this means. Let me jump over to our directory. Let's go with some class code. Ooh, look, wow, we have a lot of class code. All right. Hopefully most of this is committed. OP1. All right. We'll go main.cpp. So one of the first things you'll notice in C++ is the name of the file does not have to match the name of the class. And I'm just going to create a main.cpp file. I don't know why I made it void, but I sure did. Let's see, return 0, and we can do class. What do you want the class to be? Class.
Structures. Data
Structures. All right. Now in C++, your class has to end with a semicolon or sadness will occur. Open a new tab, G++, main.cpp. All right, and then we can just run it. Notice again, the class was named structures up here, but the file is called main.cpp. They do not have to match anymore. Yes. Well, maybe, but now you have to have header files and all this other stuff. And, all right. So what was I talking about? You had these different sections with public and protected. So basically, you could have a public function. What do you want a public function to be? All right. Int get height. I don't know if I spelled height correctly.
Yep.
Return 10.
10 height.
Yeah, it's got a height of 10, whatever that is. And then private could be something, else like, we'll do it like that. And then we'll put m height up here. And if you wanted to have another public function, so notice that you didn't have to put private in front of each, or public in front of each function. They're in their own little public and private section. By the way, you can have more than one public and private section if you want to. Well, hopefully you can see that that is a poor coding choice, but C++ of course allows you to do whatever you want, so it's perfectly fine. Let's see, does it compile? Yes. All right. All right, let's keep going with this. Oh yes, and friends. So if you had two separate classes that weren't related to each other, could they access each other's private members variables?
Friends.
Could they if they were in Java?
Oh, no.
No. But in C++ you can if you make them
Friends.
friends.
Kind of like SpongeBob.
Kind of like SpongeBob. All right, so in C++, I mean, is that a good thing?
Yeah.
No. Should classes be accessing each other's private?
Yeah, all the time. If they're
all-
friends.
If they're friends.
They're okay with it.
They're okay with that? No. Should they? They should not be. So therefore, in C++, friends are bad. Don't have friends, okay? Keep that in mind with this class. No friends. Inheritance, all right, so normally you can inherit from, all right, in Java, you're used to this, you extend one class. C++, similarly, class A can inherit from public B. Notice that there's different types of inheritance. You can inherit publicly, privately, or protectively. And you can do multiple inheritance in C++, but not in Java. All right, I'm not going to go into craziness with OOP here because that's not the point of this class. Hopefully you've had enough of OOP last class, unless you really want more.
I'll do more.
You do more? You're all about more.
Data structure in the OOP.
Well, that's what we're doing, kind of, sort of, but not really. But Java, one may implement several interfaces. We'll get into this a little later in class, but I don't want to delve too deep right now. Parametric polymorphism. Ooh, yeah. Who remembers what that is? Not a clue. Do y'all remember generics in Java?
Oh wait, like that they could be like either a char or an int.
Yeah, so you could have a list of characters, ints, student objects, etc., etc. So C++ allows you to do that as well. Well, we'll get to that later. All right, pointers. Oh yes, so in Java, a pointer was called a reference to an object. So here you'd have string str is new string. In C++, a pointer stores the memory location of something else. Y'all remember that? We're good there? All right. So for objects, you'd have standard string points to new string. Notice that in C++, string has a lowercase s. Keep that in mind. You'll get that confused all the time. And I will as well. So in Java, a pointer only exists to objects. In C++, a pointer might point to anything. Any questions about that? All right. I think this is an old slide. All right. Oh, constructor, place where you would include code that initializes the object. Default constructors, no additional info required. So C++ has this as well. So if we're up here and we want to have structures, we can set m height equal to 10 and m width equal to 20. And so that will default the height and the width to 10 and 20 respectively. Good, all compiles are run. Everyone good so far? All right. So we made a user-defined constructor, and Java and C++ luckily behave the same way with constructors, so you got nothing new here. All right, arrays. In Java, all arrays are actually objects that store the length of other information. They store the length and other information about the array, hence why the array is an object in Java. But in C++, an array is just a list of data, nothing else is stored. It's literally, as we were looking at when we created an array with our pointers, it was just one after another, after another, after another stored in memory. So yeah, you can do int x of 20 and button b of 20. These are valid declarations in C++, but not in Java. Why is this? Why can't I, when I overhear my code,
When an array was an object, so you had to.
int x of 20, and I could do structures of 10. All right, let's see, does that compile? Ooh!
Structures is built.
Nope, it compiled and ran. Why was that okay? First off, would Java accept this? No.
It's okay because C++ is different. You can do anything.
You can do anything. You can do anything. So what's happening here that is not allowed in Java?
You're making an array of 20 ints, like called X.
So I have 20 ints. Where are they stored?
X. Memory location.
No, they're referenced. The variable x points to the 20 ints. But where are the 20 integers stored?
Yeah, we haven't declared the pointer, have we?
That is actually a pointer. X is a
Oh,
pointer.
yes, okay.
We're even sneakier here. Why? See, because watch this.
Whoa.
X equals. Good morning. Data structures?
Huh?
Data structures?
No, I
Okay.
was just gonna see if it's open. That's all.
Okay, we're good.
Yeah.
Huh. X is a pointer. So if X is a pointer, what's it pointing to?
Random places in memory.
It's actually pointing to 20 integers. It is pointing to 20 integers. Because if we go down here, we go x sub 0 equals 100. And then we'll do print out x sub 0. We're going to go ahead and run it. Got the pointer, x sub 0 is 100. And I think we can even Valgrind this. Let's Valgrind this. This will be great. No memory leaks. It's on the what?
Static.
Yeah, it's on the stack. So it allocated 20 integers on the stack,
Not the heap.
not the heap. It allocated on the stack. Are you allowed to do that in Java? No. An array cannot be allocated on the stack. It had to be allocated on the heap. What's the next line doing?
Same thing.
Well, they're not integers, and there's not
Yeah.
20 of them.
So, but we would still allocate on the stack.
It allocates, what is it allocating on the stack?
10 structures.
10 structures on the stack. So we'll go structures. Let's see if we can do whoops. Structures dot get height. I'm going to fix that little.
Does that print out right even though you put it in quotes?
Well, I'm just printing out what the function call is, and then I'm actually doing the function call over here. So I'm saying when you call this, what do you get? Let's see if I type that all correctly. 10. So structures is a pointer to whatever this is, and then when I call get height, I get back 10. And yet I have no memory leaks. Why don't I have memory leaks?
It's on the stack.
Because it's on the stack, so it's automatically deallocated. Are the is the constructor being called for each of the 10 structures? No.
Yes.
Yes. Yeah, because I printed out get height and it was 10. So it's calling the constructor for each one of them.
Oh, yeah, it's hard.
Because it has to, because it's initializing it on the stack. Now, on the other hand, I'll just call this S2. Oops. I mean, what's that variable doing? create a pointer to
Has to, a structure.
a structure.
It's,
And then what value is it holding?
Undefined.
Undefined. There we go. All right.
I gotta start using it.
Undefined?
I'll be saying random places.
Random, yeah, I would not take points off for that, but undefined is a better term, far better. Random it's not random because it's somewhere between, in the memory space, between 0 and whatever, and there is a way to find out what it would be, although it's going to seem random. You might as well call it random. It's going to seem random. All right, so, and then, yeah. So, I mean, over here I could do S2 equals, this is where things get a little weirder. Is that legal?
Yes.
Yes. Because structures is a pointer, so it's just fine. All right. Okay. Let's see what else we got.
So when you do that, will it point to every like structure since it's array?
Say that again?
Since structure, like you define structures
Mhm.
as a array, so
Mhm.
will that pointer point to like every location in that array?
So the pointer points to the first element of the 10.
Oh yeah. Okay, you can define it, right? You can put 0 then.
And then 2, 3, yeah, you got it, all the way up to 9. And you can do 10, and C++ will allow you to do it. And then who knows what will happen afterwards. I'm sorry, the behavior is undefined. There we go. All right. So there's a close relationship between pointers and arrays because they're really just the same thing. So over here, I was taking S2. We're going to delete this statement, and now we can do S2 equals new structures. Good morning. So 5. All right. S2, so we're going to do 1 this time, just for the fun of it. And then we'll also go back S2. Oops, there we go. All right. So what's this line doing right here?
So it's creating a new structure array
Correct. Creating an array of structures
on the heap.
on the heap. How many structures is it creating?
5.
5. And then once it creates those structures, what does it do next?
So that's S2.2,
S2 to point to, which one is it pointing to?
the first element.
The first element of the array. All right. And then down here, I print out S2, and then I call S2 sub 1, which is the second element, dot get height. We'll go ahead and run it.
What does the get height do?
Good question. Let me fix my code error real quick. There we go. Notice that S2 is different than S standard structures. And you're asking, what's get height do? Well, get height is going to call, get height is the function that's part of structures. So we need to go up to our object structures and go down to get height, which is returning the m height, which we set as 10 when we called the constructor.
Gotcha. I'm following.
All right, just making sure. Good. Good question. Any other questions? Nope. Okay. All right, but of course, is there a memory leak now?
Yeah.
Yeah. Definitely lost. What did we forget to do?
Delete.
Just now.
Yeah. What do we need to do? We forgot to flush. Delete. What are we deleting? Just 2. All right. What happens if I try to delete structures? bet you it'll compile. Oh, it didn't. Bet you it won't. Oh, that's good it didn't. Oh no, it said warning. It's still compiled.
Got that dash hole.
Yeah, so warning. A warning just means it's gonna. I don't think this is correct, but you're the programmer. We're gonna. You know what's going on. You're good. That's what warning means. So I was like, all right, let's run it. And he goes, okay, do. Oh my goodness, free, invalid, side, blah, 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 blah. If you ever see a bunch of this, you have a memory error. And when you see that, the first thing that's going to go in your mind is, oh no, what do I do? This is what you do. You get Valgrind out and run your program. And then it says address is not thread stack in frame 1 created by main. Well, that was a little confusing. So let's recompile with debug information -G. Then let's run it. Address, so created by main, it's saying invalid free delete realloc on main.cpp line 19. Let's go to line 19. Oops, that's not what I wanted to hear. Line, oh no, I'm sorry. Line 36, there we go. Okay, good, phew. So the problem's right here. So at least Valgrind tells you this is where your problem is. And then hopefully you can look at the logic of your code and figure out what you're doing wrong. So when you see that giant gobbledygook that just came up, which is really just a stack trace of sadness, this is what you need to do. Oh, so let me all right, any questions about that? No questions. Man, you're doing great. So Java, the constructor is called with new. All objects are references. C++ constructor is called a variable declaration or explicitly through new with pointers and other situations. There's a lot of situations with constructors called. Basically, whenever the an object is created, it will call the constructor. And there's different types of constructors. But we're going to just stick with the basic ones that you're used to with Java. All right, the destructor. All right, we're going to, okay, this is starting to get a little messy, so I'm going to copy main.cpp to destructor.cpp. Open up destructor. All right, let's clean this up a little.
The destructor.
Did I misspell something?
Yeah, you left the C on destructor.
Yeah. Destructor. It's actually the deconstructor, isn't it? Destructor?
Yeah.
It's really the deconstructor. I just called it the destructor. All right, well, anyways. Destructor, deconstructor, you'll see both used. All right, let's clean this up a bit. Now, oh, this is different. Just to add even more to the mix. What is this line doing? Creating, yes.
Object structures.
Mm-hmm. On the
Stack.
stack. So it's on the stack, and then what is structures? What is structures? Is it a pointer or just a variable?
Well, it's an object.
It's an object. Well, hold on. Is it a pointer?
No.
No, it is not a pointer. It's just a variable that you use to access structure. So you're creating a variable that is a structure, calling it structures, and it's calling the constructor on the stack. This is opposed to the second line, which is creating a variable s2, which is a pointer to a structures. but we haven't created the structures yet. Let me go over here and compile it. We'll go ahead and add debugging flags. Show destructor. Let's see if it compiles. Not quite. So I misspelled something. Oh yeah, that's not going to work. Oh yeah, that'd be what? Why did this not work? Because since it's not a pointer, it's the actual object itself. C++ does not, does not know what or how to print that out because we haven't defined how you print out a structure yet. That's why that error occurred. Let's try it now. Perfect. All right, good. Now, let's say back in our private data we had let's give it a string, a name. And let's see, name equals null. And that'll be by default. Good. And if we valgrind it, we should have no memory errors. Good. All right. On the other hand, let's go. Let's create another one where we pass in constant char name, and then mname will be a new string passing in name. We'll go ahead and let's see. Return and name, and I think I'm missing something here. Yeah, because that's a pointer, so we need to dereference it. All right. Let's see if I compiled that all correctly. Nope, not quite. 8. So what was going on here? I went into autopilot. Sorry, guys. First off, we added a private variable mname that is a pointer to a string object. STD stands for standard. I really wish they chose a different acronym for that, but that's what they chose.
Is there something you can pound include to not have to do that?
Yes, and it's even worse when it comes to the acronyms because you can say using namespace STD, but then your program is using STD.
Right.
So it's up to you. I'm doing it this way just to be explicit. You can put using namespace STD on top if you want to avoid having to type in STD : in front of things. It's up to you. Either way. So mname is a pointer to a string. Our default constructor just sets it to null, so it doesn't have a name. Our other constructor actually creates a new string object on the heap if you pass it in a name and run. So now if we actually structures, and here we go, we're going to go, well, let's not do anything yet. Let's do get name first. Oh, sorry. Here we go. What's this code going to do?
It's gonna get the name, which is null right now, which is nothing.
Well, let's look. What's get name doing here?
Oh, it's returning a pointer to
Ooh, no, it's not returning pointer. It's returning a string,
string.
and it's returning the dereference of mname. Good guess.
Or do nothing.
Good guess. You're close. It's not going to return null because it needs to return a string, but it's dereferencing mname. What's mname right now?
Oh, ad name right now is null.
It's
so
null.
So dereferencing null to get, I guess, even though I have to pass it.
So if you dereference null, what happens?
Sadness.
Sadness occurs. Thank you. You get a seg fault. Well, you should get a seg fault, I should say. Yep, good. Seg fault. So we need to give it a name. What name should we give it?
Johnny Boy.
Johnny Boy?
A structure named Johnny Boy. That should have that looks
Johnny Boy. All right. Notice here, I called the constructor on the stack by putting in the parentheses right after the variable structures. So then it creates it and moves it over. Now if I valgrind this, what happens?
You have memory leaks
Why do I have a memory leak?
because you have that new name.
Yep. Oops, valgrind. Definitely lost 32 bytes in one block. Well, that's not good. And what do we use to fix this? Delete, right? But the function we're going to use is the deconstructor or the destructor. Now the deconstructor in C++, you just put a tilde in front of the name of the class, and then this function is called when the class goes out of scope or when you are explicitly deleting it. If it's on the stack, it's when it goes out of scope. When you're on the heap, it's when it's explicitly deleted. So here we'll just do delete mname. And I'll go ahead and do a printout here so y'all can see what's going on. Ooh, structures deconstructor. Alright, let's see if that compiles. It does. I'm in structures deconstructor. Notice that's the last thing printed because it finally went out of scope. Now if I valgrind it, now it was freed. So the deconstructor, here we go. In this code, where is the deconstructor for structures being called?
The very end.
The very end. So right when that return 0 happens, before it completes the return from main, it calls structures deconstructor to free the memory.
And it calls it itself.
And-
You just have to write.
Yeah, you just have to write the deconstructor and it calls it automatically. Did you have to write deconstructors in Java? No. And why not? Java does it for you.
Oh, nice.
It's amazing. All right, let's take this to the next level. Structures. What's the other name for them?
Boy Johnny.
Boy Johnny.
Good old boy, Johnny.
Got their back. Okay, so we're here now. Let's S2, 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 S2. All right. So when I call this, how many times am I going to get I'm in structures deconstructor?
Only once.
Only once. For which one?
In name.
Oh, for which structures? Because there's two of them.
The first one.
The first, the one that's on the
Stack.
stack. There we go. Just trying to make sure everyone sees or understands what's going on. Or, you know, you type something incorrectly, which I did. So you technically have to do this. And by technically, I mean definitely to dereference the pointer first, or you can use the arrow. Either one is acceptable. They mean the exact same thing. Why do you have to type this? Because S2 is a pointer and structures is not. So if it's a pointer, you have to dereference it before you can access it. And the top one is explicitly dereferencing it and then moving over. The arrow is also dereferencing it, but it gives you an arrow which a lot of people prefer, namely me. So you can see either one will work. Now we run it. There we go. Boy Johnny. All right, before I continue, anyone confused about that output? All right. Do I have any memory leaks? What's leaking?
The S2 pointer.
S2 name. Yep. Definitely lost. Ooh, indirectly lost. I like that. Indirectly lost, definitely lost, and indirectly lost. So what am I missing here?
Well, you do have to delete, wait, are we doing this today?
So we're not deleting S2. That's the first thing. But why is it reporting that something else is indirectly lost? What else is lost by this? It's actually, we're leaking twice.
2 weeks?
I know, right? So Malik has it that first off, structures 2 we're not deleting, so the actual structure itself is not being freed. But what else is implicitly not being freed?
You're using name again, aren't you?
Right. So by not freeing structures, you're also not freeing the name. So that's what it means by indirectly lost. Directly lost is 16 bytes representing structures, and that's S2. The 32 bytes is the M name of structures, so that's what's part of structures that was indirectly lost that Valgrind is reporting. Hopefully that makes some sense.
So do we have to, put the deconstructor, delete, like the actual?
So the delete will automatically call the deconstructor.
Okay.
So when I go back over here and I type in delete S2, calls S2 deconstructor before freeing memory. So it's going to, obviously that should make sense. You want to call the deconstructor before you deallocate all that memory. Otherwise, if you deallocate it, who knows what's going on. So it's going to call the deconstructor and then free up everything. So now if I run it, it runs just fine. Oh look, I'm a structures deconstructor got called twice. Which two are being called?
Being quote for name and then S2.
No, for structures
Structures.
and S2. There we go. And now if we Valgrind it, everything was freed, so we're good. This is what you want to see. Now here's a good question. Whose deconstructor is called first? And I'll put,
Delete S2.
I'll go ahead and I'll put in here so we get the name. So we have S2. Why do you think S2 is being called first?
Because if the deconstructor is called, is like the tilde structures, if that's the last thing that's called,
Right. So you're saying, well, why are you saying S2 is called before structures?
because it's the last thing that's written, but it's also written before the return 0.
Right. So this function is, when this function exits, the other deconstructor is called. So let's go and confirm that. Yep, so I'm boy Johnny, which is S2, and then structures is called afterwards while main is returning. The order probably is not that, doesn't matter that much to you, but it's a good exercise in the order of operations of when things are happening. All right, that's good. Any questions? Nope. Okay. All right. Let me go and pause the recording.